The ezLinx iCoupler Isolated Interface Development Environment provides developers with a cost-effective, plug-and-play solution for evaluating 8 physical-layer, digitally isolated communication standards. Hello, my name is David Carr, Applications Engineering Manager for the Interface and Isolation Group at Analog Devices. As a second in a series of videos, I'd like to show you how to use the ezLinx board as a debug tool for CAN communication networks. CAN networks can be difficult to debug, and it's possible to damage expensive equipment when doing so, including your PC. For that reason, an ADM3053 signal and power isolated CAN transceiver is utilized on the ezLinx board. This protects the PC from any harmful voltages that could be used in the application you're debugging. Let's get started. The ezLinx board supports CAN 2.0b operation through the use of the integrated CAN controller in the Blackfin DSP. An onboard 120 ohm termination with common mode filtering is included and can be switched in or out by connecting or removing jumpers J17 and J18. Connect the CAN-H and CAN-L lines of your CAN network to the screw terminal connector J8. Connect the board to the USB port of the PC and power up the board. Prepare to install the driver, PC application, and IP address. Initial setup instructions can be found on the ezLinx wiki at wiki.analog.com/ezlinx. Once installed, open the ezLinx sample PC application and click on the Connect button. Open the CAN configuration window by clicking on the CAN button located on the left side of the application, second from the top. To enable the CAN port, click on the Transceiver Enable checkbox. From the CAN settings, modify the CAN configuration to match your network setup. Click on the Use Changes button to open the Send Receive window. The ezLinx board implements Socket CAN that runs on the UC Linux kernel. This allows the CAN interface to support 2 types of commands, remote request commands or data commands. The CAN module can only send hexadecimal data. The colon is used to separate the 2 parts of each CAN message. Each CAN message can have both an identifier and the data. The identifier can either be a standard identifier, an SID, or an extended identifier, an EXID. The data section of each CAN message must be sent as whole bytes, or multiples of 2 hex digits. You can now send and receive remote request commands and data commands by typing the data into the send box on the left. In order to send the data, click on the Send button. Any received data will appear in the Receive box on the right. An option is included for sending data from a file. Click on the Load File button and select the file that you want to send. Click on the Open button to initiate the file transmission. You now have a safe way to monitor and debug a CAN network without putting your PC or other expensive equipment at risk. Thank you for watching. For more information on the ezLinx board, including schematics, software downloads, source code, and documentation, please visit analog.com/ezlinx. And stay tuned for part 3 of the ezLinx series, focusing on debugging I2C networks.